Hi guys, welcome back. As you can see, we're going to continue finding areas of different shapes, but today we are going to put a little bit of a spin on it. So if you take a look at your learning targets, it says I can find the area of triangles and quadrilaterals by first using the Pythagorean theorem or trigonometry to solve for a missing dimension, and I can solve for a dimension of a figure given its area. So that's the same as what we did the other day, but today we're going to really focus on using some Pythagorean theorem or trig in order to find the areas of different shapes. All right, so let's take a look here. When we look at this first figure, we can see that it's definitely a parallelogram. So if we write the area equals base times height, it's nice and easy, right, if we have the base and the height. But when we take a look at this picture, we can see in our figure that we have this height drawn in there, but we don't actually know what it is. So I'm going to go ahead and put an H there. I know it's a little hard to see on the dark gray, but we're going to put the H there because that is the height. And if that is the height of our figure, we know that down here then is the base. And since it's a parallelogram, we know that that's going to be 18. But we are going to have to figure out what that height is. So hopefully you guys can take a look at this picture and see that we have a lovely right triangle with a 60-degree angle and a hypotenuse of 12, and we are looking for the height of this parallelogram. So, based on the last chapter that you guys just took a test on, and you did really well, we can use some SOHCAHTOA here. So let's go ahead and write that just in case anybody needs a refresher. SOHCAHTOA. Here's our 60-degree angle. This is our opposite side and our hypotenuse, which means we're going to have to use sine in order to solve for h. So the sine of 60 degrees is going to equal the opposite side, which is h, over the hypotenuse, which is 12. And we multiply by that 12 to get h alone. So h is going to equal 12 times the sine of 60. And if we put that into our calculators, if you've got the small yellow one, then you will be able to get that down to 6 rad 3. Notice up in the directions that it does tell you if we're going to round, do not do it until the last step. So if you put that in your calculator and you get a decimal, I do want you to just leave it as 12 sine 60, and we'll plug it in the calculator all at the end, okay? So continuing here, now that we have the height, we can plug it in. So area is going to equal the base, which we said was 18, times the height, which we just found to be 6 rad 3. Now if you want to, you can leave it in radical form, and that would be 108 rad 3. And then remember your units, inches squared. But I am going to go ahead and round it. And that, if we plug it in the calculator, we should get to 187.1 inches squared. So that one was using trig in order to solve for a missing piece of information to find the area. If you had noticed that that was a 60-degree angle and you know your 30, 60, 90 ratios better than you know your trig, you can go ahead and use those also. I do not care which way you do it. Sometimes, though, if that's not a special part of a special right triangle, then we are going to have to use trig. So usually I'll just go ahead and do trig because then it's one way fits all. Okay. Let's take a look at the next one then. The next one, we can see that it is a triangle, and we know then that the area of a triangle is 1/2 base times height. So we can write down our formula first, and then we have to remember the height has to be perpendicular, which means that's our h, but there's no number written there, so that's kind of a problem, right? The other thing we want to figure out is that is perpendicular to which side of this triangle. That happens to be this. This is the 7. So the base of our triangle is 7. We need to find the height. So if you take a look just at that triangle there on the outside, hopefully you notice that it is a right triangle because it's perpendicular. So we have the height. We have that side as 3. We have that side as 5. And we can use Pythagorean theorem. So remember that Pythagorean theorem says c squared equals a squared plus b squared. And c is always going to be our hypotenuse. It's the side that's across from the right angle. So in this case, that's the 5. 5 squared is going to equal h squared plus 3 squared. And we can start to simplify. 5 squared is 25. 3 squared is 9. Subtract that over, and we get h squared equals 16. And take the square root, we end up getting that the height of this triangle is 4. So we can take that and put it back up here in our formula then. We know the base already was 7. So we can do area equals 1/2 the base, which is 7, times the height, which is 4. And if you go ahead and put that in your calculators, you should get it to be 14. Now on this figure, there were no units drawn in there for you. However, I do want you, if there are no units, to just put u squared for units squared so that I can see you recognize that anytime we find an area, the units become squared. Okay? That is one example of each. So we're going to do the notes a little differently today. We are going to skip some of the questions, but I think number 3 is a really important one, so we're going to keep doing that one next, okay? When we look at this, we can see that it's a rhombus. You are going to have to remember all the properties of a rhombus, you guys. So one of the most important properties that we're going to have to know when we're doing questions like this is that on a rhombus, the diagonals bisect each other. So if you need to jot that down, that might be a good idea. Diagonals bisect each other. And that means, of course, that some of those segments are going to be congruent, which means AE is also going to be 12. And it means that BE is going to be congruent to ED. Now make sure that you do not make the mistake of making all 4 of them congruent to each other. That is not the case. They bisect each other, meaning they cut each other in half. They are different lengths though. Okay? In order to find the area of a rhombus, we are going to have to do 1/2 diagonal 1 times diagonal 2. And remember, a diagonal goes from corner to corner. So if we say, oh, I don't know, let's start with AC. So AC, I'm going to call that my diagonal 1. Okay? AC is going to equal D1. And because I know that it was bisected, 12 and 12, that means I get AC, which is D1, is 24 meters. Then I'm going to take a look at BD. I'm going to call that my diagonal 2. So BD equals diagonal 2. And I don't know what that is. I need to figure that out if I want to find the area of this figure. So another important property that we have to know then is that the diagonals are perpendicular to each other, which means they make a right angle. So I'm going to go ahead and call BE, I'm going to just call that X, because I don't know what it is. But I know that if I find it, it's also the same as ED, right? And I'm going to take that triangle and just kind of draw it out here so I can see what's going on. This is X, this is 12, this is 15. Well, based on the last chapter, we know that if we have 2 sides of a right triangle, we can use Pythagorean theorem to find the other side. So it's going to be very similar to the process we did over here with Pythagorean theorem. So C squared equals A squared plus B squared. C has to be the 15 because that is the one that's across from the right angle. So 15 squared is going to equal X squared plus 12 squared. And you'll want to pull out your calculators and make sure you are getting the same numbers that I am, because you guys know that I can sometimes make mistakes. So 225 is equal to X squared plus 144, which means we should get 81 equals X squared. And we can go ahead and take the square root to get that X is equal to 9. Now make sure that you are careful. We only called this little section X, which means BD is not equal to 9. It's actually equal to 18 because both of those sections are 9. So BD then is 18. Now that we have both of our diagonals, we can go ahead and actually find the area of our figure. So I'm going to go ahead and just put it up here. I wrote some extra notes for you guys and kind of ran out of room. Sorry. But 1/2 D1 is 24 and D2 is 18. And if you go ahead and plug that in your calculator, you should get it to be 216 meters squared. Okay? Now, like I said before I did that problem, some of these are kind of similar. So number 4 is really similar to number 1. I'm actually not going to do it in the video for you guys. If you want to give it a shot and then have me check your answer tomorrow, I'm more than happy to do that. Or if you're kind of confused by number 1 and you want to work through number 4 with me tomorrow in class, we can do that as well. But for right now, we are going to go ahead and skip it. Okay, so go ahead and flip your packets to the next page, and we are going to take a look at number 5. Now, hopefully, you guys can take a look at this and tell me that it is a kite because it has 2 sets of consecutive sides congruent. And to find the area of a kite, we know that it's 1/2 d1 times d2. It's that same formula we actually just used for the rhombus, right? Special things about a kite, we know that the diagonals are perpendicular. And we also know that this diagonal happens to be bisected, which means this segment here is also going to be 20. Okay? Now, we need to identify our D1 and D2 again, right? So let's call the one going up and down, let's call that our D1. We know that D1 then is equal to 40. We can add those two together. Now take a look at diagonal 2, though. We don't know anything about it. Unfortunately, we are going to have to solve for it, right? That's kind of what this chapter, or this section, is about. So I'm going to go ahead and put an X down here, and I'm going to put a Y right here. Notice that I did not use the same variables, you guys. Keep in mind that those are 2 different lengths. This one is not bisected, so I'm going to have to use different variables in order to solve these triangles. Let's take a look then at this triangle down here. I'm just going to kind of shade it in orange a little bit, and I'm going to draw it underneath here for us, or over here actually. So if I do that, that's the X that I decided to put there. This is the 20, and this is 25. So I can just use Pythagorean theorem in order to solve for X. Keep in mind, the side across has to be your C value. Side across from the right angle has to be your C value. So C squared is equal to A squared plus B squared. 25 squared is equal to X squared plus 20 squared. And again, if I were you guys, I would be taking out my calculator right now and making sure that Miss J is not making a mistake, because we know that she can do that sometimes. So 625 is equal to X squared plus 400. We can subtract that 400 over. 225 is equal to X squared. And go ahead and take the square root, and we should get down to 15. But now that is only one piece of our diagonal 2, right? So our second diagonal, which I colored in purple, we know that so far it's 15, but we're going to need that Y part also, right? So let's take a look at that triangle also. Maybe I'll use my pink. Okay, let's take a look at this triangle up here. And let's draw it over here, see if we can figure out what's happening. This is 20, this is 35, that's my Y value. We're going to do the exact same thing. Again, we have 2 sides of a right triangle. We're just going to use Pythagorean theorem. So there is my C value. C squared equals A squared plus B squared. 35 squared is equal to Y squared plus 20 squared. 35 squared ends up coming out to 1,225. And that's equal to Y squared plus 400. So we get to Y squared equals 825. And when we take the square root of both sides, we get Y equals 5 times the square root of 33. So if you put it in your yellow calculator, that's what you'll get. If you end up getting a decimal because you don't have the yellow calculator, you need to just leave it as the square root of 825. Because, remember, we don't want to round until the very, very end of our problem, because we don't want that to be a factor in us getting the problem wrong. So now I have found my diagonal 2. This entire length, 15 plus 5 root 33, is my D2. So I am going to go ahead and plug that into my area formula. So area equals 1/2 of 40 times 15 plus 5 root 33. Sorry, I kind of ran out of room there, guys. But if we go ahead and put that in the calculator, we will come up with 874.5. And again, there's no units anywhere on this picture, so I'm just going to go ahead and put u squared. Now, if you wanted to leave it in terms of a radical, you could. It's kind of messy, so I would say not. But if you really wanted to, the answer would be 300 plus 100 root 33, and then units squared. So if you want to leave it as a radical, you can, but really, in this case, that's pretty ugly. Go ahead and get it to be the decimal then, okay? I'm going to skip number 6 also because it's very similar to number 5. And really, you guys, the only reason I did number 5 for you, they both use Pythagorean theorem, right? You guys know that well enough. The only reason I did it is because you did have to do it twice. So I wanted you to see an example of that. So again, with number 6, if you want to try it, and I can check your answer tomorrow, that's great. If you want to do it with me in class tomorrow, we can do that too. Or you can leave it to be a review question for later in the chapter, okay? We are going to go ahead and jump down to number 7 really quick, and then actually that's going to be our last example, okay? So we are now going backwards. We're given the area, and we want to find a specific measurement. So area of a trapezoid is 1/2 the height times base 1 plus base 2. And right now we have the height, that's this 2. This is our B1. Here's our B2. So the only thing we don't know is the B2. So we can go ahead and plug in what we know. 8 equals 1/2 the height times base 1 plus base 2. And we can start to simplify. Now we luck out that 1/2 times 2 just ends up being 1. So it really just goes away, and we get 3 plus B2. But sometimes that's not always going to happen, you guys. There might still be a number there, in which case you can either distribute and then keep solving, or you could divide both sides by that number and keep going from there. Either way that you're more comfortable with it is fine. But we can then get to B2 is equal to 5, and don't forget your units. Now numbers 8 and 9 are really similar to the ones that you guys saw in the video the other day, and they're similar to the ones that you guys did in class. So I'm not going to do them, but if you, again, want to try them and have me check your answers, I am more than happy to do that. All right, so that is it for today, and I will see you guys tomorrow in class. Bye.